Welcome to SQL Server on AWS, choosing the right strategy session as part of Data, Databases, and Analytics online series. My name is Rita Ladda. I'm a Senior Database Solution Architect at AWS. In this session, I will go over some of the key business drivers to move SQL Server to AWS Cloud. We look at various options and migration strategies for Microsoft SQL Server in AWS. I have a demo at the end of the session to showcase heterogeneous migration from SQL Server to AWS Aurora using Schema conversion tool and database migration service. So let's get started. To understand why you should run your SQL Server workloads on AWS Cloud, let's first talk about some of the key drivers of why businesses move to cloud. Customers move to cloud for elasticity, agility. With AWS Cloud, you can spin up resources as you need them, deploying hundreds or thousands of servers within minutes versus weeks. This allows for faster feature rollout, low-risk experimenting, increasing pace of innovation. Partnering with AWS, you as a customer inherit a remarkable rate of innovation, ensuring that your workloads are running on advanced, latest platforms. Additionally, AWS provides best-in-class performance and reliability for SQL Server workloads, with a broad range of instance types, managed services to reduce complexity, various security options, and compliance certificates for your most security-sensitive workloads, an impressive set of tools to support migration. Customers have been running Windows and SQL Server workloads on AWS longer than any other cloud provider. These are the 6 different migration strategies customers implement when they are planning migration to AWS. Retain, retire, and replace options do not really apply to migrating SQL Server to AWS Cloud. So in this session, we will focus on rehost, replatform, and refactor option. When you are planning migration of SQL Server to cloud, it's important to generate detailed inventory of your SQL Server workloads. Understand interdependencies, RTO or recovery time objective, and RPO or recovery point objective requirements, performance targets, and licensing options. Understanding this information will help you in deciding target database platform and define your migration options. So what are the options of running SQL Server on AWS Cloud? You can rehost SQL Server to EC2, replatform to Relational Database Service or RDS, or refactor to purpose-built databases. With rehost or lift and shift approach, you can select operating system version and type like Windows or Linux. You have full access to operating system and SQL Server. You can bring your own licenses or choose license included option. Replatforming to RDS makes it easy to set up, operate, and scale SQL Server and relieves you of all the heavy lifting of configuration and database management. RDS supports license included model with license cost baked in RDS pricing. You don't have to purchase licenses separately, and you only pay for the resources that you use. Refactor or database modernization is all about selecting the right tool for the job. AWS offers 15 purpose-built databases for various use cases and workloads. So for example, for relational use cases, we have Amazon Aurora. For key value data, you can use DynamoDB. Amazon DocumentDB for storing documents. AWS Neptune for highly connected graph datasets. AWS Elasticache for in-memory databases. QLDB for immutable ledger datasets. Moving to cloud-native, open-source, compatible, relational database like Amazon Aurora eliminates SQL Server licensing costs, at the same time providing performance and availability of commercial-grade database. Migrating to cloud is a journey. Many of our customers select EC2 as an option to get in the cloud quickly for elasticity and scalability and lower total cost of ownership. After experiencing the benefits of cloud and developing AWS skills, customers move to modernization phase with managed services and purpose-built databases. So when should you choose EC2 versus RDS? Let's look at some of the differences between the two. RDS is all about taking care of undifferentiated heavy lifting of infrastructure management, where AWS manages hardware, installation and patching, one-click setup of high availability and disaster recovery solutions, storage auto-scaling, and automated backups. EC2 is self-managed option, where AWS takes care of physical infrastructure and OS install, and you are responsible for everything in the stack above operating system, like database install and maintenance, designing and implementing high availability and disaster recovery solutions. All of these tasks require a great deal of expertise and consume a lot of time. Consider RDS as an option first, as most of the database management activities are done by AWS. So you can focus on high-value business tasks like optimizing your application and designing new features which differentiates your business. Many of our customers choose SQL Server on EC2 option when they have legacy workloads with older SQL Server versions or have an application requirement for full access to operating system or sysadmin access to database, or if they are using SQL Server features not currently supported in RDS. So these are some of the features supported in RDS and EC2 for SQL Server. You can install older version of Microsoft SQL Server or SQL Server Developer Edition on EC2, or bring your own licenses. Both options support SQL Server integration service, reporting service, and analysis service. RDS has automated many of the database administrative tasks, making it easy to manage databases. Let's look at some of the features of RDS. Most business-critical production applications need to be highly available. You have option to deploy RDS in multi-AZ environment for high availability to ensure business continuity. If you're not familiar with AZ, it stands for Availability Zone. Each region has multiple availability zones, and each availability zone consists of multiple data centers. Multi-AZ deployments provide increased availability, data durability, and fault tolerance for your database instances. Synchronous replication is set between the primary instance and standby instance using always-on availability group or database mirroring, depending on version and edition of SQL Server. So if you are a DBA working on creating high availability solution, this is what you have been setting up and managing. With RDS, this is fully managed feature where you can set up multi-AZ deployments with one click. In case of service disruption, RDS automatically fails over to secondary instance, so database operation can resume without manual intervention and with minimal disruption. Another feature of RDS SQL Server is in-region read replica. RDS read replica gives you ability to scale your SQL Server horizontally, where you can offload your read workloads from primary database instance to read replica. For example, analytic or reporting type of queries that can tolerate latency in data updates. Read replicas are available in Enterprise Edition with multi-AZ setup and use distributed availability group for asynchronous replication. Setting up read replica in RDS is fully automated and can be configured with few clicks. Monitoring is critical to maintain reliability, availability, and performance of database. RDS for SQL Server has various built-in monitoring tools like CloudWatch, Enhanced Monitoring, and Performance Insight to help you baseline your workloads and debug and diagnose issues related to databases. With Enhanced Monitoring, you can monitor the operating system of your database instance in near real time. You also get visibility in database activity with Performance Insight. You can, of course, continue to use native SQL Server tools like SQL Server Profiler, extended events, and dynamic management views to troubleshoot problems. With Performance Insight, you can understand the database load, which represents average active session in the database. You can get information about top SQLs, top wait types, top users, and databases. You can select from dozens of operating system and database metrics, including SQL Server perf_mon counters, to help analyze performance bottleneck. Now that we understand rehost and replatform option, how do we move these workloads to AWS? Our focus will be on these 5 options for database migrations. Some of the migration mechanisms work equally well in EC2 as well as RDS, while some are more geared towards one of these platforms. I will highlight the differences as we move along. You can migrate Microsoft SQL Server to AWS using SQL Server native backup and restore. AWS offers a broad set of tools and services like AWS Storage Gateway and AWS Data Sync to bring your database backups over to AWS, followed by AWS S3 and Amazon FSx to store your database backups in AWS. If your database is too large or would take too long to transfer over the wire, AWS also offers Snow family of products, which can transport terabytes to exabytes of data into AWS. This option will work for both EC2 and RDS SQL Server. You can use full, differential, and log backup to minimize the downtime for migration. You can also use SQL Server native replication capability to migrate your database to AWS. If you're already using SQL Server transactional replication on premises, then you can add additional subscriber on AWS. SQL Server replication creates publication database snapshot and sends it to subscriber on AWS. Once snapshot is applied, replication sends all changes from publisher to subscriber to keep both databases in sync. Once the target database is in sync and validated, you can cut over to AWS to complete the migration. If your database is too large, the initial snapshot can be applied through backup delivered to AWS via Snow devices, as we talked earlier. This migration method applies to RDS and SQL Server on EC2. If you're currently using SQL Server always-on availability group on premises, you may extend your on-premises availability group to AWS. This migrates data and replicates changes to databases in the cloud till you are ready for cutover to the cloud. Ensure you have appropriate network bandwidth for data transfer. Best way to find is to try it out. With AWS pay-as-you-go model, you can experiment with minimal risk as you only pay for what you consume. Again, if your databases are large, you can use Snow devices for initial synchronization. This option works for SQL Server on EC2. Another option is to use Cloud Endure migration tool to migrate SQL Server infrastructure from on-premises or other cloud provider to AWS. Cloud Endure is an agent-based solution that needs to be installed on source server. Once installed, the agent replicates the data at block level to EBS volumes in cloud. After initial load is complete and changes start flowing through, you can launch the target infrastructure for testing. After testing and validation, you can cut over to AWS. This solution applies to SQL Server on EC2. If your environment primarily consists of virtual machines, then you can also use Server Migration Service or SMS, which is a no-cost tool offered by AWS. SMS can migrate from VMware, Hyper-V, or Microsoft Azure to AWS. AWS SMS is an agentless service, which allows you to replicate live server volumes to AWS and create Amazon Machine Images or AMI. SMS migrates the infrastructure as is, so you carry the same operating system, database versions, and configurations to cloud. This option applies to SQL Server on EC2. What if you want to avoid the complexities of setting up replication or extending availability group? For this case, AWS offers Database Migration Service or DMS. DMS is highly resilient and self-healing service. It continuously monitors source and target databases, network connectivity, and replication instance. In case of interruption, it automatically restarts the process and continues the migration from where it was stopped. DMS can enable near zero downtime migration. So far, we have looked at replatform and rehost migration options. So what else can we do? Let's look at the last R of migration, which is Refactor in AWS. Many of our customers are facing challenges with commercial databases. They are expensive, lock customers in, and offer punitive licensing terms. Customers are looking for purpose-built, cost-optimized, enterprise-grade database for their critical workloads and want to move away from legacy databases. Cloud-native, AWS-managed databases merge the flexibility and low cost of open-source databases with robust enterprise-grade features of commercial databases. Refactoring your database to cloud-native solution relieves you from the lock-in of the old guard, proprietary, and often expensive vendor offerings. Refactoring is also the most rewarding method for long-term business outcomes, as it truly accelerates your pace of cloud innovation by continuously reducing cost while increasing performance, resilience, and responsiveness. We already introduced DMS for SQL Server to SQL Server migration. However, DMS can also perform heterogeneous migration across databases like MySQL, PostgreSQL, Amazon Aurora, and Redshift. Refactoring your database to one of these offerings usually requires changes to database schema and associated application code. And that's where AWS Schema Conversion tool comes in. AWS SCT automatically converts your source schema to compatible schema for target platform. If your source schema cannot be converted automatically, AWS SCT provides guidance on how you can create equivalent schema in target database. SCT can also review your application code in an attempt to identify and modify your code to make it compatible with your target engine. AWS SCT integrates with AWS DMS to migrate schema during database migration. One of the most popular targets for refactoring SQL Server is Amazon Aurora for PostgreSQL. As I said earlier, typically refactoring SQL Server to Aurora PostgreSQL requires refactoring the database and the application to ensure compatibility. Understanding these challenges, AWS developed Babelfish, a new translation layer that enables Aurora PostgreSQL to understand commands written for Microsoft SQL Server. Babelfish understands the SQL Server wire protocol and T-SQL, Microsoft SQL Server's query language. So you don't have to switch database drivers or rewrite all of your application queries. Babelfish enables faster, lower risk, and low effort refactoring. This feature is currently in preview. After signing up for preview, you can enable Babelfish with just few clicks. Let's look at some of our customers who have realized benefits of migrating SQL Server to AWS. Enkid Group, based out of Vietnam, has been operating indoor playgrounds for kids for past 10 years. They faced issues with frequent crashes of their payment app, especially during peak usage, leading to customer dissatisfaction. They re-platformed their mobile applications in AWS Elastic Beanstalk and RDS SQL Server backend. This improved their scalability and availability, leading to improved customer experience, at the same time reducing operational costs by 30%. With automated code deployments and RDS managed databases, they could focus more on business innovation. Since migrating to AWS, Enkid has doubled the number of tiny vaults from 30 to 60 and branded retail outlets from 10 to 42. Another AWS customer, JobWhite, which is a leading recruiting platform that helps thousands of companies source, hire, and onboard top talent. Their Microsoft SQL database was too slow for customer requests, with high cost and 20 hours refresh time. They migrated from Microsoft SQL Server to Aurora MySQL, lowering their cost and improving response times by 40%. They eliminated monthly database maintenance and reduced refresh times from 20 to 2 hours. Overall, this improved reliability and availability of their application, leading to better user experience. So let's look at the demo of Microsoft SQL Server Refactor to Amazon Aurora using Amazon Schema Conversion Tool and AWS Database Migration Service. I have pre-created the source and target. As a first step, let's go to Schema Conversion Tool and create a new project to convert and migrate schema from source to target database engine. We will select SQL Server for the source and Aurora as destination. Next, let's connect to source database by providing the database endpoint that was pre-created as part of this demo. SCT will connect to source SQL Server and load the metadata and schema for conversion. We will also create a transformation rule to make sure schema name is mapped correctly, especially where source and target database engines have differences in implementation. This transformation rule makes sure that target database name does not have schema name appended to it. We will create the rule to remove the schema name suffix from the destination. Connect to target AWS Aurora database, we can get the database endpoint that was pre-created from AWS console. As part of this demo, we will migrate DMS sample database. Next, we create a detailed assessment report to understand compatibility between source and target. Report summary provides high-level overview of the effort required for migration. This report evaluates storage and code objects and shows what objects can be converted automatically. For the objects that cannot be converted automatically, the report provides guidance on manual effort involved in converting these objects, like if it's a simple conversion, medium, or complex conversion. Report also provides action item details about the conversion, including code that needs to be converted. For the purpose of this demo, we will do automatic conversion to create schema objects compatible to destination engine. Let's convert the schema from source to target database engine. Once complete, you can see schema objects that are converted to target format. At this stage, we still have not created the schema in Aurora yet. So if you connect to Aurora database, you do not see DMS sample. Let's go back to SCT and create the converted schema on target database by applying the changes. This step does the migration of schema to target database. Let's go back to target and validate. Migration of schema is done, as you can see here. If we look at the tables, we find there is no data yet. Now that the schema is migrated from source to target engine, next step is to migrate the data using AWS Database Migration Service. AWS DMS has three components: replication instance, where tasks run; endpoints, which are connection to source and target database engines; and database migration task, which does the data migration. As part of this demo, I have pre-created the replication instance, which is basically an EC2 instance underneath. So let's create the endpoint. Let's first create source endpoint pointing to RDS SQL Server. We will provide connection information manually. Let's enter the password and database name to be migrated. We will leave rest of the configuration values to default. Make sure source database can connect to replication instance, as this is where the task will run. Next, we create target endpoint pointing to AWS Aurora database. We provide the connection information manually again. So let's enter the password. We keep rest of the configuration to default for this basic demo. We make sure that there is connectivity between target and replication instance. Now that the source and target endpoints are created, next step is to create database migration tasks to migrate the data. Migration tasks run on replication instance. Select the replication instance, source and target endpoints. DMS can do full load as well as replicate changes. We will do full load as part of this demo. Schema is migrated using AWS Schema Conversion tool. So select Do Nothing. We keep LOB values to default, enable validation, and always a good idea to enable monitoring. We want to migrate all tables from DBO Schema to AWS Aurora, so we add a selection rule to migration task. We also want to make sure schema name is correctly mapped to the database name. So let's add a transformation rule for correct mapping. renaming the schema to database name. We keep rest of the configuration to default and make sure this task starts at creation. It can take few minutes to create the task. Once the task is running, you can go to Table Statistics tab to see the details about tables that have been migrated. You can check the rows that are migrated and validate if validation is enabled. Let's go to Target and check the data. As you can see, data is migrated. We go to SQL Server, make sure this data is there. So this is a short demo to showcase migration of SQL Server to AWS Aurora using Schema Conversion Tool and AWS Database Migration Service. So to summarize, we went over benefits of moving to AWS Cloud. We looked at 3 options and migration strategies to move SQL Server into AWS Cloud. We walked through demo of refactor of SQL Server to Amazon Aurora database and talked about some of Amazon customers who have migrated their SQL Server workloads to AWS Cloud. These are some of the resources to get you started. If you want to learn more about data, databases, analytics, and machine learning, please visit our resource hub. We have many new resources to help you jumpstart your data journey on AWS. Start your learning journey with AWS training and certification to become data-driven by clicking on the links provided here.